Okay, I'm live with Rust MLOPs Projects here, and I'm going to try some more Rust MLOps stuff. One of the things that I was diving into a little bit is seeing if I could do a static compilation of PyTorch, and I could just give it a try. And I was using ChatGPT to help me out with this. And if I go to distrolist CLI here, that might have been where I was playing around with it, where I was under PyTorch maybe, PyTorch Rust Docker maybe. That's might have been where I was at. Let's look at this one. Yeah, so I think I was looking here. So basically Docker size is huge because this is one of the MLOps problems is how do I get this thing into a container that's small, right? Because and also, well, we could do this actually, which would be interesting. So I'm gonna cd, I'm gonna create one more project here, which is I'm gonna cd into PyTorch Rust Docker. So PyTorch Rust Docker, and what I'm curious about is actually a is how to actually get PyTorch in a container. So we see this first stage, build this thing. That's one potential, and I could actually do this. I could go to ChatGPT here, and I could say, again, how do I install PyTorch into a Rust Docker container? I could just use the PyTorch bindings here. That could be one thing that I do. So let's look at PyTorch Docker. Let's see what we got here. So here's a Docker container that was updated pretty recently, actually. Let's see, PyTorch Docker Rust. How about that? PyTorch Docker Rust example. That. Oh, here we go. Look at this. Docker build. Cargo run. Wow. I want to do embedding, but we need to implement this. Wow, this looks pretty interesting here. So I'm going to star this and Docker file. What do we got? So from Rust, we install this stuff. We install libtorch. Download the weights files. Well, let's just try this, actually. That might be a good thing to try, actually. Let's just, without doing anything tricky, let's see if I can even get this working. So I'm going to make a subdirectory, and we can say make dir, and we'll call this new Docker approach torch or something like that. If I go into here, just say touch Docker file. Now, let's go here. Let's paste this in. And then let's look at the instructions. What do they got here? Download Docker support file. And we can say Docker build. So we can do this. Now I need to touch a README here. And we can do that. And then we can do that. So let's do this first. So let's Docker build. Ooh, that's not good. Oh, because I need to copy this person's code. So that's fine. Let's go here. Let's go to local, and let's just let's see, get clone. Wait, get clone into existing directory. How do you do that again? You do don't clone, do a init, fetch origin. Kind of annoying. Oh, get init, remote add, get fetch. I don't want to do all that. I'm just going to go up a directory. I'm going to remove that rm-rf new docker here. And then what I can do is we can do and I'm going to do this, get ignore so I don't check it in. Ignore. And let's do that here. Ignore. Okay, so get status. Let's go up here. Hit add here. Adding pre-train. Adding Docker PyTorch. Okay. So let's cd into there. Oh no, I need to go into PyTorch Rust Docker. And then I need to go into this. cd into tcsh. Okay, now if I look at the README here, we're going to just do this. We're going to say Docker build tcsh. So let's see what happens. And then again, if we look at the Docker file, it's going to install CMake and Clang. It's going to install PyTorch 1.9. It's going to download the weights for ResNet 18. And let's see if this works. If so, this does open up some very interesting possibilities of how to get PyTorch invocation inside of a Docker container and then make it potentially smaller in the future as well. Well, that did work. So now let's look at the README. Let's see if we run this. Run it. And then we say cargo run. So, okay. Cargo run. I see. So this could take a bit because it didn't actually build it. So I think the issue, install lib, well, actually, let's see here. Download pre-trained model, install libtorch, build it. So I am curious, actually, this approach. So if we get libtorch and we set this up, could I actually invoke it that way? And we're copying it here. So the build did seem to go maybe fast, which would mean, can't F open cargo run. Well, didn't work. So that was currently that approach seems to have an issue. But yeah, this is an interesting problem. But I could go to ChatGPT here and say, how can I build a Docker container with Rust and PyTorch? Let's see what ChatGPT says. You need to create a Docker file with a Rust and then install PyTorch and dependencies. Here's a step-by-step guide. Create a new file named Docker file in your project directory. Open the Docker file and add the following content. Use it as a base image. Install this. Copy the Rust project. Copy, build the Rust project. Build. Well, that's not exactly what I want. So let's say I want PyTorch bindings. I want PyTorch inside a binary. Binary. You can use the following. Create a new file. Let's see here. Working directory, install dependencies. Copy the Rust project to the container, build it, set the command to run the binary. In your Rust project, add the tch creates to that. Now you can use PyTorch in your Rust code. Here's a simple example. So that would be interesting to try to see if I can use ChatGPT to help me build this out. Maybe let's try it out. Docker build. Okay, so let's try this. Let's try this approach here. So I'm going to go up a directory. I'm going to say cargo new. We'll call this one Chat GPT torch. Try that. See into that, and then let's do everything it tells us to do here, which is let's create a Docker file. So let's paste this Docker file here, and probably if we look at Rust version, probably want 167. Okay, so that looks good. That looks good. And then your binary, we can call the cargo check. We can call the binary this, like that. We can do that. Release. Okay, let's try that. And then for the dependencies, we can so this is interesting. This might be when it was built, or at least the latest version of the crawling was done. So look, we can see 11 as the latest one. So let's switch to 11. And then for the source here, let's copy this. Let's see if this actually works. And then we can build we can say Docker build. We can just say, we're going to call this one PyTorch or Pi, or we'll call this Torch Rust. How about that? Torch Rust. Ooh. Oh, must be lowercase. Sure. Rusts. All right. How long does this take to run? This will be interesting to see. So again, if we look at the Docker file, what's going to happen is it's going to use Rust 167. It's going to install the PyTorch stuff here. PyTorch lib. I guess these are the dependencies that may be necessary. We'll find out. And if we open up another terminal here and we do htop, you can see that it does appear to be pretty busy. It's doing a lot of work. And even it's using quite a bit of memory, actually, 14 gigs of RAM. You can see that something's using 14 gigs of RAM. I guess I could toggle to see what is using that much RAM. Docker build. Okay, now it's going to compile. And this is where it could take a little bit of time because if I recall correctly, it downloads a pretty big PyTorch build from there's a build script that'll take quite some time to put PyTorch inside of this container. But again, if it works, it works. So be curious to see how this would actually get configured. So again, what's happening is if we look at Docker here, it's under this part, which if we go to cargo is just using the Rust PyTorch crate, and we see that it's using just a really kind of a hello world example here. But again, what will take a little bit of time is that it does download PyTorch into this container, which would take a little bit of time. So this might take a few minutes to, oh, there we go. So it's compiling here. We can see it's definitely using the CPUs here, which is great. It means that it's fully utilizing this machine, compiling all the PyTorch stuff. And then if we look at, I mean, this is kind of cool, actually. Set the command to run the binary is that if you could run the binary, that is interesting. So that gives me some hope that I could build a distroless type Docker container. So let's see here. Hopefully this passes. Yeah, I believe this is the step that does take a little bit of time here because it will actually pull PyTorch into this container. So again, we can see it's working. There we go. Look at this. Done. Okay, so now we say Docker image ls. We've got Torch Rust here. You can see 4 gigabytes. That's not horrible, right? It's not. It could be a lot worse. And then we say Docker image or Docker run inactive RM and Torch Rust. Does that work? Okay. RM. Or I think I can just do this. Response. Oh, no such file or directory. Unknown. Creating shim. Let's see here. Docker run. How about that? Let's just say Docker run. Docker run. Torch Rust. Here. Failed to start process. Target release ChatGPT. Now, what was the output of the command here? I guess it kind of hit it. Well, not exactly what I wanted, but it's a good first start here. All right, well, that's a good start to end with, and I'll keep going on Rust MLOps projects.